Hello everyone, this is Sichamba Jacob. Okay, in today's video we'll be answering some exam questions from 2018 GCE paper 2. Okay, question 1, we were given a matrix and they asked us to find the value of x. So inside the matrix here there is x, this and this, so they want us to find the positive value over x. So what we basically do here, we follow the procedure of finding the determinant. Since they have said the determinant of A is 12 over here, so we follow the procedure. So once we do finding the determinant, the solution will look like this. This is how the solution will look like. So you get this major diagonal, you multiply this by this, it will give you 2x. So this is what we've done here. 2x multiplied by x, we're getting 2x squared. And then minus 3 multiplied by 2 over here, 3 multiplied by 2, we're getting 6 over here, which is equal to 12. So thereafter we can add 6 to both sides, this side and this side, and 6 will be somewhere here, and then we can add over here, we'll have 18, and then 6, this 12 plus 6 will give us 18. We can divide by 2 so that we get the value of x. We solve for x. So once we divide by 2, we get this, what is here over here. We find the square roots of both sides. So here we remain with x, this power disappear, and the positive value of x is 3, because here it's giving us two answers, negative 3 and 3, but we get the positive value, which is 3. Alright, so we jump on question 2, which is over here. So for question 2, this one, the answer will look like this. This is how the answer will look like over here. So what did I do? They've said we find the inverse of A. So for us to find the inverse of A, we get the matrix we've been given, and remember in our previous answer or previous question, we found the value of x to be 3. So since the value of x is 3, you get this 3, put it where x is, you put it here, here and here, and when you solve here you have 6, because it will be 2 multiplied by 3, which is 6, and then here it will be just 3. Now for you to find the inverse, switch the major diagonals. So 3 will be here, and then this 6 will come down here, and then for the minor diagonal, change the signs. It was positive, put negative, positive here, put negative. If it was negative, you put positive. So you switch the signs, and then you get 1 over the determinant. That's how we find the inverse. You multiply after switching the major diagonal, and then you multiply, and here changing the signs, you multiply the inverse of the determinant, 1 over 12. 12 is the determinant. The determinant, remember in the question they said the determinant is what? 12. So you write it this way, multiply it by whatever is in the bracket, so you have something like this. This one will come here, this one here, it will look like this, this one here like this, and then like this. And then after you can solve. Here 3 can go into 12. How many times? 1 time here. 4 times. So here it's 3, 1, here 4, and then here 2 into 2, 1, 2 into 12, 6, just like that. Even here, this is for this one. This is the answer. We go to the next question, which is question 2. So for question 2, we have been asked to simplify. The solution will look like this. This is the answer, t over 12v s squared. So how did I do this? I checked what is here. It's multiplication. So I copy this over here, and this over here, this here, and this here. I start dividing. I know that 7 can go into 28. How many times? 4 times. I've written here. So 7 to 7, 1. 7 to 28, 4. And then go to s. S can go into s cubed. So s into s, 1. And then s into s to the power 3, it's s to the power 2 over here. And then this t squared can go into t cubed. This, so t squared into t cubed, it's t, only t will remain on top here. I come to this one, 5 can go into 5, can go into 5 one time, and then 5 can go into 15 three times. Over here, this and this can cancel, this and this are the same, they can cancel, and then v can go into v squared. So v into v, 1, v into v squared, it's v. So on top here we have 1, over here 1 times 1, 1 times t, t times 1, t times 1, over here t times this one, it will just be t. On top only remain with this t, all these will go or remain with t. Down here we have 3 by 4, it's 12, and then this v is over here, and then s over here. So the solution will now look like this. Thank you very much. We go to the next question, which is question 2b. So question 2 is over here, 2b. They've given us a geometric progression, and they say the third term, this is the third term, and then the fourth term is over here, and then they say find the first term and the common ratio. So we want to find a and r. We want to find these two things, a and r. So what we basically do is we follow the statement. They have said the third term is what? It's 2/9. Over here they have said the third term. What is the third term? Okay, they have said third term is 2/9, and then the fourth, let's do this, fourth term is what? Is 2/27 over here. So we can solve for these two by following what we've been given here, this and this. They've said the third term is over here and the fourth term is here. So for us to find this, we use the nth term formula. So this is a formula. This is how it looks like. So what we do, we know that our n here will be 3, and then the term at 3 is 2/9. So it will be 2/9 is equal to a, and then r, n we said it's 3, we know it's 3, third term. And then over here we say, put a comma here so that we separate these two things. We'll get this, and then say a power n will be now 4, this 4 minus 1. So we have two equations, so we need to solve these two equations. How do we solve them? We'll say 2/9 is equal to a power, here we can solve, we have 2, 3 minus 1 is 2, and then here we have something like this, is equal to a r, this is a r, 4 minus 1 is 3, and then we have these two equations. So we can make one of the equations, maybe we get this one, we make a subject of the formula, and then we come and plug it in here in the second equation. So we can divide by r squared, both sides. So this will go here, we have 2/9 r squared is equal to a. So we have made a subject of the formula. So we'll get this a, put it in the equation, so it will look like this in the second equation. Where there is a here, we put 2/9 r squared. You see, I've just gotten this, put it where a is. So this and this can go. So we have 2/27 is equal to 2/9 multiplied by r squared, because this 2, not r squared, just r, this to this, it's r. So at this point we can divide by 2/9. So once we divide by 2/9, we solve here to look like this. Yeah, this is how it will look like. So this can go into this 3 times, this and this will go. So our r will be 1/3. This is our r. So since we have found our r, we can get this r, we put it here, we solve for a. So it would be 2/9. Here this r is 1/3, so we put it here, 1/3 squared is equal to a. So now here it can look like this, or it will look like this. Here we have 1 over 9, because this the power, this is 1 to the power 2, it's 1, 3 to the power 2, it's 9, which is equal to a. So this 9 and this can go, will remain with 2. So our a is equal to 2. So a is 2 and then r is 1 over 3. So we go to the next question. So this one, number 2, the sum to infinity. So the sum of the first 5 terms, the sum to infinity is over here. Now the sum of the first 5 terms. So we write the formula. The formula looks like this. So this is the formula for the sum of geometric progression. So it will look like this: sum of the first 5 terms. So a, we found our a was 2, and then r is 1 over 3. Here it will be power 5. N is 5. That's why I've put a 5 here. N is 5. Then 1 here over 1 over 3 minus 1. So here we can solve. Once we solve, we'll have something like this: 1 to the power 5 and over 3 to the power 5. It will look like this. So from here, we're just solving what is here. So from here, we can do this. Yeah, we find the common denominator, then it will look like this, and down here the common denominator will be 3, so it will look like this as well. From here we solve, we have negative 2, 4, 2 over 2, 4, 3. Over here this will be negative 2 over 3. So if we solve nicely, we do our work the way it's supposed to be done. If we can flip this one, so it will look like this. It will be 2 multiplied by what is here on top. So 2 multiplied by, so negative 2 multiplied by negative 2, 4, 2. We have 4, 8, 4. Multiplying these over, so here to be negative over 2, 4, 3 times this one will flip. Since it's a division of fraction, so it will flip, so it will look like this. So this can go into this. So we have 2, 4, 2 over this into this. So 2, 4, 3 divided by 3, can it go? Yeah, it's 81. So here we have 81. So then to finish it, you can reduce if you want. If you want, you can leave it like this. There is no harm if you leave it like this, it's okay. Okay, we now go to the last question, sum to infinity. Sum to infinity, the formula looks like this. So our a, we know, we found a as 2. R, it was 1 over 3. So we can solve here. So once we solve, we have 3 here over 3. Find the common denominator here. Once we solve, we have 2 over 2, 3. And if we solve nicely here, we have 2, and then here, this will flip. Since the division of a fraction, it will flip. So this and this will go. So of 3, our answer will be 3. Alright, thank you very much. So keep on watching my videos. I'll finish all the questions in the next coming videos. Thank you.